The contemporary battlefield is an unforgiving ecosystem, defined by speed, precision, and overwhelming destructive power. For the 70-ton behemoths we call main battle tanks, survival is not guaranteed by mass alone. It is secured by layers of hidden, highly classified technology, fighting a desperate, constant war against kinetic and chemical energy. The primary threat is the hollow charge warhead, a shaped charge weapon designed not to crush, but to melt and pierce armor through hydrodynamic pressure, creating a focused supersonic jet of molten material, capable of slicing through meters of solid steel. The answer to this existential threat, developed in deep secrecy decades ago, lies in composite armor systems, most famously exemplified by Chobham. This protection is not homogeneous steel. It is a meticulously engineered sandwich of metallic alloys, ceramics, and often proprietary non-metallic materials, each component designed to fulfill a specific role in deflecting, shattering, or diffusing the incoming energy. When a high-explosive anti-tank heat round strikes, the ceramic matrix within the composite array fractures, violently disrupting the cumulative jet and forcing the molten stream to expend its energy laterally, rather than thus protecting the inner volume. This engineering marvel is the single heaviest component of the modern tank, representing a continuous, painstaking sacrifice of speed and agility for the essential gift of time, the few precious milliseconds required to survive the initial impact. Furthermore, this passive protection must also count modern kinetic energy dense needle-like rods traveling at hypersonic speeds. The composite layers introduce tumbling and stress, forcing the rod to break up before it reaches the crew compartment. This material science race, the perpetual quest for the optimal arrangement of density, hardness, and elasticity, is the silent hidden guarantor of armored warfare viability, a monumental achievement in classified material technology that transforms an otherwise fragile steel box into a moving fortress of calculated risk management and specialized, layered defense against overwhelming odds, defying the laws of battlefield physics through sheer ingenuity and expense. If passive armor is the static defender, the active protection system, APS, is the lightning-fast automated guardian, representing the paradigm shift from merely absorbing a hit to actively preventing it. This system is the tank's electronic nervous system, constantly scanning the 360-degree environment, using a sophisticated suite of sensors: high-resolution millimeter-wave radar, electro-optical sensors, and acoustic detectors. The challenge is immense, identifying a threat, whether it's a wire-guided missile or a rocket-propelled grenade, calculating its exact trajectory and velocity, and launching an instantaneous countermeasure, all within the space of 300 to 500 milliseconds. This reaction time is significantly faster than any human can perceive. Once a threat is confirmed, the APS deploys a dual strategy. The soft kill element attempts to confuse or divert the incoming projectile using multispectral smoke infrared jamming flares, or electronic countermeasures that sever the missile's guidance link. Crucially, the hard kill component is triggered when soft measures are insufficient or the trajectory is too immediate. This involves launching small, high-velocity kinetic interceptors designed to explode harmlessly, a meter or two from the tank hull, obliterating or drastically destabilizing the projectile systems like the Israeli Trophy or the Russian Arena. Turn the tank into its own close-range air defense platform, capable of intercepting munitions that travel at nearly the speed of sound. This capability demands unprecedented computational power, processing millions of data points per second to distinguish between legitimate threats and harmless debris or environmental clutter, the inherent violence of the interception. A small controlled explosion inches from the vehicle is a necessarily calculated risk, the cost of deploying a real-time shield that renders many legacy anti-tank weapons obsolete, fundamentally reshaping the doctrine of close-quarters armored combat and providing the invaluable, ephemeral gift of survival. The true measure of survivability lies not just in deflecting the threat, but in preserving the human element within the metallic shell. Even if the external armor defeats the penetrating jet, the enormous energy transfer can lead to little secondary effects. Inside the crew compartment, one of the most insidious threats is spallation. Fragments of armor and metal, breaking off the inner wall, and ricocheting violently within the confined space, effectively turning the interior into a grenade. To counteract this, modern tanks employ advanced anti-spall liners, often thick layers of Kevlar, or high-performance synthetic materials like dynamite, which catch and neutralize these high-velocity fragments. mitigating the risk of crew injury from non-penetrating hits. Furthermore, the risk of catastrophic internal fire, stemming from ruptured fuel lines, ammunition, ignition, or hydraulic fluid leaks is mitigated by sophisticated, automated fire suppression systems. These systems use optical and thermal sensors placed strategically throughout the engine bay and crew compartment, capable of detecting a flash fire and deploying a specialized inert gas, often a halocarbon derivative, in less than 150 milliseconds. This ultra-fast response is essential to starving the incipient fire of oxygen before it can take hold, saving both the machinery and the lives within. Equally critical is the protection against environmental hazards. Modern MBTs are equipped with nuclear, biological, and chemical NBC protection suites, which pressurize the crew compartment, using filtered air to create a sealed microenvironment that prevents the ingress of contaminants. This system ensures that, even when operating in the most toxic environments, the crew can breathe clean air and maintain operational efficiency. This combination of internal safety measures, from fragment suppression to automated fire defense and life support, defines the technology of resilience, acknowledging that the crew is the most vital and the most vulnerable component of the entire warfighting platform, demanding continuous complex technological support to ensure sustained viability. This power is married to complex pneumatic suspension systems that allow the tank to move rapidly and maintain a stable firing platform over extremely unforgiving terrain, ensuring high speeds without sacrificing crew endurance or weapon accuracy. This ability to shoot and scoot is a core survivability doctrine relying on advanced drivetrain technology to achieve operational unpredictability. Furthermore, modern tanks fight not just with steel and gunpowder, but with information. They are highly integrated nodes in a vast command control, communications, computers, intelligence, surveillance, and reconnaissance. C4, ISR network, real-time data feeds, satellite connectivity, and advanced battle management systems allow the crew to possess a comprehensive, three-dimensional understanding of the battlefield, anticipating threats long before they become visible, and coordinating movements across the terrain with unprecedented precision. Signature management completes this evasive strategy. The tank's massive heat output, particularly from the engine and exhaust, makes it a glaring target for thermal imaging systems. Consequently, advanced thermal shrouds, exhaust cooling mixers, and specialized low-emission exterior coatings are employed to reduce the infrared signature. Even visual detection is countered through complex digital camouflage patterns designed not just to blend with the natural environment, but to confuse computer vision algorithms. This synthesis of overwhelming power, rapid maneuverability, and stealthy signature reduction ensures that the greatest hidden technology keeping a tank alive is its ability to remain unseen, untargeted, and outside the enemy's lethal envelope, turning massive inertia into tactical fluidity. As the technological arms race continues, the future of tank survivability pushes toward autonomy, integration, and directed energy. The next generation of protected vehicles will rely heavily on artificial intelligence to manage the sheer volume and complexity of defensive countermeasures. AI fire control systems will autonomously differentiate between soft and hard kill requirements, allocating resources, and managing multi-threat scenarios faster than any human can process, leading to the potential introduction of unmanned turrets and eventually fully autonomous defensive systems. Perhaps the most revolutionary hidden technology on the horizon is the implementation of directed energy weapons, due specifically high-power lasers as a hard kill solution. Current kinetic interceptors are finite and expensive. Lasers promise unlimited, near-instantaneous intercepts at the speed of light, vaporizing or disrupting incoming missiles and drones with precision heat. This shift requires immense onboard electrical power generation and thermal management, new layers of hidden technology, ensuring the massive power draw does not incapacitate the vehicle. However, the pursuit of absolute protection always confronts a philosophical paradox. Every layer of defense adds weight, complexity, and staggering cost. The cost of a modern MB is exponentially higher than the array of missiles and rockets designed to destroy it, perpetuating an asymmetrical economic reality. Ultimately, the hidden technology that sustains the tank is not just the composite armor or the active defenses, but the continuous, relentless intellectual investment dedicated to preserving the lives of the handful of soldiers inside. This relentless technological pursuit confirms that the main battle tank remains a viable, terrifying force multiplier, constantly redefining the physics of defense. In the face of ever-evolving destruction, ensuring its survival is a testament to unwavering human ingenuity and the unquantifiable value placed on the crew's security.